Okay, so this video is to prove that the derivative with respect to x of arc sine is equal to 1 over the square root of 1 minus y squared. Okay, that's our proof. That's what we want to prove. There's an interesting little background that I'm going to be sharing with you. So first of all, you guys know that whenever you're looking at sine, well, let me back up a little bit here. You guys know that arc sine, hopefully, is a function where you plug in a coordinate and it tells you what angle gives you that coordinate. And the inverse of arc sine is just sine itself. So sine of that angle gives you the y coordinate on your unit circle. Now, you can arbitrarily use the variable x. Matter of fact, if I'm going to write it like this, it should have been dy, because I'm using y as my variable. But it could just as easily be x. The variable is interchangeable. But I chose to make it y because you guys know that the sine function is the y coordinate on the unit circle. Okay? So, on the unit circle, this is all background stuff, so I'll tell you when the actual proof starts up. But on the unit circle, if you have some given angle, which we'll call theta, you can imagine a triangle here, okay? So if we're talking about sine theta equals y, that's opposite over hypotenuse. So y is y over 1. So my opposite would be y and my hypotenuse would be 1. Now what I'm going to do is I'm going to use the fact that if sine of theta is equal to y and this is y and this is 1 because of that, I'm going to use that to figure out what this adjacent side is here using Pythagorean's theorem. Pythagorean's theorem says that leg squared plus leg squared equals hypotenuse squared. Now 1 squared is just 1. And then I want to solve for a. So what I'm going to do is I'm going to subtract y squared on both sides. And I get the following. And then I take the square root. And that actually could come out to be positive or negative depending on which side of the triangle you're on. But there it is. So a comes out to be 1 minus y squared. Okay? So I'm going to come up here and I'm going to replace this a with the square root of 1 minus y squared. All right. So, knowing that, I think we're about ready to begin our proof here. So let's go ahead and begin. So first of all, I'm going to start off with the fact that we have arc, and I'm going to continue using y as my variable. Arc secant of y, right, is what I want to find the derivative of. What I'm going to do is I'm going to do the same trick we did with the inverses, and I'm supposed to be sine, not secant. So let me, sorry about that. Arc sine of y. I'm going to do the inverse of that, and that should just come out to equal y, because when you do plug an inverse function into the function itself, the sine cancels the arc sine, you're just left with the y, just like we had on our last video about the derivative of an inverse, right? And that's going to be the approach that we take here. So what I'm going to do is I'm going to take the derivative of both sides with respect to y. Oops. No equals there. The derivative of y with respect to y is going to be 1. Anytime these variables match, it's just 1, right? Over here, we have a chain rule. We have to do the derivative of the outside function, which is sine, multiplied by the derivative of the inside function, which is what we're trying to find. So the derivative of the outside function sine is going to be cosine. Don't change the inside, right? And then we're going to multiply that by the derivative of the inside, which is arc sine. Remember, this is the piece I want to figure out what is the derivative of arc sine. So I need to get that by itself, and that's my next move. I'm going to divide both sides by that cosine of arc sine y there. So that gives me the following. Now we're going to do some interesting little substitution moves here to simplify this, okay? First of all, arc sine y equals something very simple. Arc sine y is equal to theta, some angle, right? So I'm going to rewrite this in the following fashion. But we can't leave theta there because we want everything to be in terms of y. So I'm going to come back up here and I'm going to figure out what is cosine of theta. Well, if you guys don't remember what cosine is adjacent over hypotenuse. So it's going to be this adjacent over hypotenuse, 1. So this over 1 is just the square root function because anything divided by 1 just stays the same. And we end up with our final step, which states that the derivative of arc sine of y is equal to 1 over the square root of 1 minus y squared. And once again, I've got y's there instead of x. The variable is arbitrary, so it doesn't really matter which variable you use. But there's our proof for that. So it involved this interesting little geometry trick up here where we turn sine into a triangle and find a third side. Then we do the inverse stuff with some back substitution, and we end up with the answer. I'm going to go ahead and do a proof for arctangent and arcsecant. After that, I'm going to go ahead and stop with the proofs, and that'll close us out on this extra credit assignment. The other 3 I'm not going to do. They're all very similar. So I think the other 2 will be enough. So we'll see you guys in the next video.